Well, thank you for joining us with this session on weights in a lift. It's a mechanics module, and it's a question that relates to a lift, either accelerating downwards or vertically upwards or vertically downwards, and there's an object inside the lift. So let's have a look at this question here. We've got a lift of mass 200 kilograms is being lowered into a mine shaft by a vertical cable attached to the top of the lift. The crate of mass 55 kilograms is on the floor inside the lift, as shown in figure 2. The lift descends vertically with constant acceleration. So we're coming down with some sort of acceleration. There is a constant upward resistance of magnitude 150, so there's a resistance in the opposite direction on the lift of 150 newton. The crate experiences a constant normal reaction of magnitude 473, so that's between the floor of the lift and the 55 kilograms, a normal inside that lift of 473 newtons. Find the acceleration of the lift. Now with these type of questions, I like to split it up into two parts. I like to look at it as a system, just as this 55 kilogram system, or as a complete 255 kilogram system. So the lift and the mass together is 255, so the force downwards is 255 G. Now there's an upward force of 150 newtons. There's an upward tension in the cable, which is that force exerted on the lift by the cable. That's the T that I've given. And they want, first of all, find the acceleration of the lift. Well, let's just talk about this system inside the lift, this 55 kilogram mass. Now, if the lift were not moving, then that 55 kilogram mass would be exerting a downward force of 55 G. And therefore, the upward force would be 55 G of the floor of the lift onto the mass. But the thing is, the moment it starts accelerating downwards, this tends to, like if you're standing in a lift and it suddenly starts going down, you feel slightly lighter, don't you? And when the lift is going to go up, then you feel slightly heavier, you're pushing down. So as the lift goes down, this mass is going to get slightly lighter, and that depends on the acceleration. So there's a force upwards that is will take away from this 55 G force, which is a product of the mass times acceleration. Now we know the mass is 55, so there's an acceleration force upwards of 55A when the lift is moving down. Let's look at these overall. That will bring this result down. Now we're told that there's a 473 Newton upward. Therefore, we will say that our force down, 55G, and take away our force up, which is 55A. That's our force due to acceleration, which is cutting back on that force because you feel slightly lighter, will be 473. Now before with the acceleration lift, just 55 times 9.8, that's 539, you see. Now, if the lift wasn't moving, the normal would be 539 newtons. But it's 473 because the lift is moving down, so it lightens it by that difference. And that difference is the 55A. So let's just work this out. We take this 473, bring that 55A across, and 539 without the movement minus 473, that is the normal with the movement. There is a 65 Newton difference, and that is attributed to the 55 times the acceleration of the lift. So 66 divided by 55 will be our acceleration, which is 1.2, and that is meters per second squared. And that is our acceleration of the lift, 1.2 meters per second squared. Okay, part B now. Find the magnitude of the force exerted by the cable. I'm going to look now at the red system. That's the complete system. I'm now going to treat the lift and the mass as one object, and I'm going to call that 255 kilograms, which brings the force down. So let's have a look at this system. We've got 255 force G down. Take away our resistance force, 150. Take away our force opposing that in the cable of T, and that will equal our overall mass times acceleration, which is 255 times A. We already know what A is, and it is 1.2. That's 255 times A. And T is the only unknown, so really all we have to do now is go T equals 255 times 1.2, so 306. Bring that, that's a negative, bring that over to be plus 150, bring that over to be minus 255 times 9.8, which is 2,419. Negative T will equal 306 plus 150 minus 2499, and that equals negative 2,043. Therefore, T will equal 2,043 newtons, and that is the magnitude of the force exerted by the lift on the cable. And there we've talked about the inside system and the system as a complete. Notice when we're talking about the inside system, we're looking at 55 kilograms, so the acceleration is 55A. When we're looking at a complete system, we're talking about a 255 kilogram mass, so it's 255A. And we're just looking at the force down on the lift, taking away the force up on the lift. For the force down of the mass minus the acceleration force to be the normal on the floor of the lift. All right, so that is a brief support system, support help for hopefully this type of question. Until I see you or talk to you next, can you find other questions which are similar? And until then, stay happy.